All right, class, can you hear me?
Yes.
Yes, madam.
All right. So for this question number one, I just want to recap a little bit with you. Can you tell me at what time or in which question we need to find reaction quotient and we need to comparing Q with K? Any clue? Nobody have any clue? Hello?
Direction.
But first of all, if you can't answer these questions, right, first of all, what is means by reaction quotient?
at any time.
At any time. What thing is at any time? Apa benda yang at any time? Kalau reaction quotient kan. Okay, if we refer to the definitions over here, reaction quotients defined as the numerical value or the ratio between your product and reactant. Okay, product and reactant raised to the powers, right? So it occur at any time. Now, whereas for K, it refers to equilibrium constant, then K will only happens at equilibrium. We doesn't say Q cannot have at equilibrium. Q can also at equilibrium, but it can also at the beginning of the reaction, towards the end of the reaction. So it's at any point throughout the reaction. Okay, and then it is the relationship between the product and the reactant, similar like our K. So the clue of the questions, you can see it from the question itself. Okay, first of all, if you see, if let's say I have first one, if you want to find the Q, first of all the species, okay, they have info. All species have concentration, or maybe they have partial pressure. So at this time, you don't know whether the reaction is going to the right or going to the left, towards the product or towards the reactor, because all informations you have. You have the concentrations for reactant, you have the concentrations of the product. But then if you look previously in our previous question in exercise 2, right? They only give you the starting material. They only give you reactant, no product is given. So that means we know the reaction must proceed to the right hand side. Sebab tak ada product kan. So reaction dia mesti proceed forward in forward direction. But then in the case where you have all information, reactant ada info, product pun ada info. Pada masa ini awak kena carikan Q. Okay. And then the second clue over here is you have no idea in which direction. So it's actually linked between two of these points. You don't have idea whether it's already at equilibrium or is at the beginning or is already towards the end. No idea, right? Then you have to find the Q. Then comparing with your K. Lepas tu cari awak punya Pacman. Okay, so if for question number one over here, you see questions give you KP value. So are you going to find QP or QC? Clue dia sangat obvious kan? Kau you want to find QP or QC?
QP.
QP.
QP. KP, QP expression dia adalah sama. Kalau soalan bagi awak KC, lepas tu awak kena cari QC. So QC, KC dia punya expression adalah sama. Okay, so soalan dekat at puzzle yang last question, some of you making mistake Madam tanya QP has the same expression, ada yang pilih QC. Macam mana QP akan sama dengan QC? Ada yang lagi kelakar, QP sama dengan KC. Langsung tak kena. Okay, so make sure QP, KP, they have the same expression. But it is taking at different point of the reaction. Okay, so in the given temperature, 0.10 atm of each component is placed in the container. So this one is already referred to the partial pressure. And then you look back into your equation. So all species are in gases already. All species in gases already. And then it say for each component, that means for NOBR, you have 0.1. atm. For NO, you have 0.10 atm. For bromine gas, also you have 0.10 atm. Every species. So it's placed in a container, and then it asks. So this question is quite straightforward. It straight away asks you in which direction. This is the time when you know we need to find Q and comparing with K. So is this reaction at equilibrium? If not, in which direction it will proceed? So determine whether more NOBr or more bromine is formed. The second part of the question is after you have known the direction. After you have known a direction, so the reaction will produce more product or more reactant. Then you have to determine. Okay, so let's check your answer. Okay, so for exercise number 3 over here, you can see. So again, come up with your reaction quotient. For this question, you don't have to come up with ice table. Now, because Q at any point, right, it can be an initial inside your ice table. So kalau awak nak lukis ice table, tak ada masalah. Dia cuma dekat kolom yang pertama sahaja. Okay, so Q expression, so pressure of your product on the top, so pressure of NO raised to the power of 2. Kejap ya, Madam cari highlight pen because of the coefficient 2 over here. Okay, and then for pressure bromine, coefficient 1, so raised to the power of 1, divide by the partial pressure for NOBr. Again, raised to the power of 2 due to this coefficient 2. And then after that, you just substitute the value. Okay, so remember about this one, yeah? The value of your partial pressure. Okay, value of the partial pressure 0.10, 0.10. They are all the same. So you just fill in accordingly only. Tak payah darab 2, tak payah divide 2 or etc. No need. Straight away fill in. So ikutlah pressure NO. Kita ada dekat sini 0.10. So isilah terus. Pressure bromine. Dekat sini pressure bromine 0.10. So isi terus dekat sini. Okay, and then for pressure NOBr as well. And finally, you can find your QP value equals to 0.1. So to answer back last question from Sue, Madam have figured out the QP, KP, KC value that doesn't fix. Sometimes it can be very high, sometimes it can be very small. So it is not necessary to have a range. So to correct yourself also. So no specific range for KC or KP. Is that all right? Can everyone follow up until this point?
Yes.
Yes, madam.
Boleh ya? Okay. So lepas tu kita compare lah QC, KC. So QC, KC, QC very small. Smaller than your QC. But QP smaller than your KP. So the reaction is not at equilibrium and it will move to the right in your equation until Q equals to K. The Q equals to K means until equilibrium is reachieved. So this one is a simpler form lah, until equilibrium is achieved or until Q equals to K. It refers to equilibrium. All right. So any questions until the equilibrium shift? Boleh ikut?
Boleh,
Dapat
madam.
jawapan betul?
Betul.
Betul. Okay, so since the reactions proceed to the right hand side, then we will see the reaction. So awak kena tahu macam mana nak interpret. If the reaction shift to the right, that means the NOBr partial pressure will decrease. NO partial pressure and Br2 partial pressure will increase because now reaction proceed to the right, you are producing more product. So more product, more Br2 is formed. Sebab soalan hanya tanya NOBr dengan Br2 saja. So give the specific formula. Okay, more Br2 is formed. Alright, so any question for question number 1? Ada soalan?
Madam.
Tak ada. Okay, if no question, then we look at questions 5. Okay, so first of all, again, we want to interpret the questions. So in inorganic chemist studying the reactions of phosphorus halide mixes 0.1050 mole PCl5, 0.045 Cl2, 0.045 PCl3. So volume also given. Now over here you have 0.50 liter. So in which direction will the reaction proceed? So in your answer, which direction do you get?
To the right.
To the right. Okay. So again, lah, you have the equation or you have the information for all species. So question number 5 over here. All right, so you have the information, but it's given in number of mole. So you need to convert lah into your concentration. So using the formula lah, concentrations equals the number of mole over volume in liter. So figure out each concentrations of all the species. Okay, kenapa kita cari concentration? Why do we find concentration? Kenapa tak cari partial pressure?
Sebab dia dah bagi KC.
Sebab dia bagi nilai KC. So you know I need to compare QC with KC. And C refer to concentration. That's why you need to find concentration. Okay, so PCl5 0.21, Cl2 0.09. Same thing for PCl3. Okay, so QC expression, please check your own answer. QC, you are using the square bracket to present concentration. So product on the top, reactant on the bottom. And you get the value 0.03, which is much smaller than, do you get the same values?
Yes.
You get the same value. Anyone got a different values? Ada yang dapat jawapan berbeza? Ke semua sama?
Sama.
Okay, class, Madam hope you can do your own exercise. Otherwise, when Madam proceed to the next question, nanti awak blur. So masa awak buat soalan, awak akan nampak masalah awak sendiri dekat mana. So it is important for you to try the questions. If you got questions, if you got problems lah, you can text Madam. Kalau awak tak minta tolong, memang Madam tak tahu awak ada masalah. So QC smaller than KC, reaction is not at equilibrium, so the reaction will proceed to the right until Q equals to K. So please check your answer, yeah? So any question for question number 5? Ada soalan? Tak ada?
Tak ada.
Tak ada, okay. Kejap ya, kalau okay, Madam want to try something. Okay, past year questions, let's see question for chapter 6. So we see the last few years one. This one is 2020, 2021, yeah? So you look at the questions. So first one, 5A, suggest 2 changes that can be made to increase the yield. So this one will be in chapter 6.3, which is the next subtopic we want to enter. Okay, and then you look at question number 5B. So giving you an equation, you're giving a KC value, and then determine the direction. So it's more or less the same what you have practicing. Okay, so determine the direction, you need to find QC. So QC expression, substitute the values, comparing with K, and then determine the direction. So dekat sini ada 5 markah. Kalau dia adalah written exam, you need to show all working steps. Okay, you need to show all working steps. But since exam will be online, but subject to changes, we wait for announcement. So you have to know all the steps. So we haven't know the final decision yet. Mungkin tiba-tiba suruh awak balik untuk buat written exam. Tak tahu jugalah. So kena tahu dia punya jalan kerja ya. Okay. And then we look at the year on 2020 lah. So 5A, again, you are given an equation. Okay, calculate the concentration at each gas at equilibrium. So this question is what we done in uh, the second part untuk our punya exercise 2. So it has nothing to do with the direction. So dekat sini kena ada I stable, initial concentration, change in concentration, concentration at equilibrium and so on. So boleh practice untuk awak punya past year questions. Has already updated. Cuma madam kena check balik dekat Google Drive. Okay, dekat Google Drive rasanya sampai 2019, 2020 only. Okay, tapi awak boleh cuba ya. Ada banyak soalan boleh cuba. So sesiapa yang nak minta soalan, dekat sini lah awak cari. Okay. Okay, so that is for 6.2. Majority is about calculation. 6.2, more to explanation. Okay, 6.3 is concept, theory, and explanation. Okay. So are you ready for 6.3?
Yes.
All right, so 6.3, Le Chatelier principle. So in our learning outcome, you need to know what is the definition for Le Chatelier principle. You need to apply this principle to explain the effect of the following factors on a system at equilibrium. So that means these factors, how they will affect the equilibrium shift. Is it to the left, to the right? In explanation. Yang tadi 6.2 awak buat kira-kira kan. Sekarang 6.3 kita buat explanation pula. Okay, so the factors, we have concentrations of a species. We have the pressure or the volume. Pressure, volume considered as one factors. And then we have the factors additions of inert gas. Addition of inert gas, it divide into two. At constant volume, at constant pressure. Okay, and then we have the factors of temperature, and we have the factors of catalyst. Okay. So for the Le Chatelier principle, it is defined. Now, this is the definition of the first sentence in your notes. So it is saying that when a system at equilibrium is subjected to change, that means you adjust the concentration, you adjust the temperature, you add inner gas. Okay, it's subjected to change. So that means you change something of the reaction. So we call this one as the disturbance. Something disturb your system. Okay, so when a system at equilibrium is subjected to change, the system will adjust to counteract or to reduce the effect. Adjust, another meaning we can say how they respond to these changes. Kalau dia naikkan concentration, macam mana sistem ini dia respond. The response is in order to reduce the effect of the disturbance. Kita tambah concentration, sistem dia akan respon nak kurangkan concentration. Disturbance dia naikkan temperature, kita nak respon, sistem akan respon untuk turunkan temperature. So that is Le Chatelier principle. But this one is in general, yeah, the definition in general. There is different explanation also. You can Google and see what is the explanations for Le Chatelier principle. But Meda have found the easiest for you to understand. So again, when a system at equilibrium is subjected to change, the system will adjust to counteract or reduce the effect. Okay, so the disturbance, we can divide into concentration, pressure or volume, and temperature. and also the rest of the effects lah. The rest of your effect stated in the learning outcome. Ada juga addition inner gas dengan catalyst. Ada dua lagi point. So bila ada disturbance, kita nak reduce dia punya effect. Okay, so factors affecting equilibrium position. We have concentration, volume. So ini repeating concentrations, pressure, volume, addition inner gas, kita ada dua. Lepas tu temperature, ada catalyst. An overview for you. Okay. So the explanation in terms of sentences. If there are disturbance, the system will try to reduce the disturbance and return the system to the equilibrium position. Equilibrium position is our target. Macam mana pun kita nak maintain sistem itu ataupun reaction itu dekat equilibrium position. Nak maintain dia Q sama dengan K. Okay, so now you imagine you are playing a seesaw. So if for the first diagram over here, the seesaw is imbalanced. Let's say this is my reactant A. Reactant pula orang A, orang B. Student A, student B. Okay, so when student A having a higher weight, okay, higher weight, that means awak punya seesaw dia akan tenggelam dekat sini kan. It will get heavier. So same concept. Okay, same concept. If I say I have more concentration or more reactant A, so the mass also will be bigger or larger. Then therefore, it will bring the system towards one side, which means the system is no longer at equilibrium. But remember, our target is to bring this system back to the equilibrium position when two of these concentrations, they are balanced. Tapi bukan cakap concentration dia mesti sama tapi equilibrium dia kena sama. This one you can refer back to the characteristic of our dynamic equilibrium. Q kena sama dengan K, rate forward, rate reverse kena sama. Lepas tu concentration dia kena constant. That is the dynamic equilibrium characteristic. Do you get this? Boleh faham untuk seesaw diagram ini?
Boleh, madam.
Bagi tahu M untuk Lee Chatelier principle kita nak buat apa? Target Lee Chatelier nak buat apa?
Nak respond kepada disturbance untuk adjust, untuk return kepada equilibrium position.
Dia nak bawa balik kepada equilibrium position. I remember the main purpose of Lee Chatelier principle. Okay, so let's look at the first factors. Concentration is the easiest explanation. Now we start with the easiest first. Okay, so sebenarnya awak boleh baca sendiri tau. Madam bagi nota penuh, cuma dekat nota bawah sini ada contoh soalan. So if you read through yourself, you can actually get the idea of Lee Chatelier principle. But no problem, Madam will go through this with you. But at the same time, if you want to highlight, you want to jot down your notes, you can do so, yeah? Okay, so change in concentration. The equilibrium position will shift the direction that will reduce the effect of the disturbance in order to re-achieve, re-attain, re-establish the equilibrium. So ini adalah awak punya definition Lee Chatelier jugalah. Boleh guna untuk sebagai statement or definition for Lee Chatelier principle. And these three words, you can choose either one. Re-achieve, re-attain, re-establish. Regain, because you want to move back to equilibrium position. Okay, so disturbance can be either disturbing the concentrations reactants or the concentrations product. So this depends on the questions. So sometimes they adjust the product, sometimes it adjusts the reactant. So you need to pay attention. What is the disturbance? Okay. And to remind yourself also a very important point, value of K, your equilibrium constant, at a constant temperature will remains unchanged. So K tak ada berubah kalau apabila temperature dia masih sama. Okay. And then second important point is over here. If in your equation, okay, if in your equation, hold on lah, saya tengok siapa message. Okay, kejap ya. Alright, so the second important point over here, if in your equation you have solid, you have liquid, okay, you can ignore it. It won't affect your equilibrium position because solid and liquid, they all have constant concentration. Okay, constant concentration. So it will not affect the equilibrium position. That means it won't shift to the right, it won't shift to the left if you're adjusting this solid and liquid. Do you get me?
Yes.
Okay, so let's look at this example. PCl3 gas, Cl2 gas is a reactant, and then it is in equilibrium with PCl5 as the product. Okay, and then for your QC expression, also given la product over reactant. So let's say the first disturbance, if I add Cl2, oh, you're adding more reactant at this point. So that means the concentrations of our Cl2 will increasing. Okay, will increase. So when your concentrations of Cl2 increase, it means that this system is no longer at equilibrium. So you have QC smaller than Kc. Why? Cl2 now having higher concentration. Okay, Cl2 concentration, now if you're looking at the QC expression, kalau concentration Cl2 dia tinggi, maksudnya QC value awak rendah. So QC smaller than Kc, the system is not at equilibrium. Tapi awak hanya kena fokus lah, dia bukan dekat equilibrium. Kalau tak reti macam mana nak determine QC besar ke QC besar ke QC kecil, tak ada masalah. Penting awak kena tahu dia bukan dekat equilibrium. Okay? So in order to re-achieve your equilibrium, we need to apply Chatelier's principle. Okay, so system will try to reduce this disturbance. So how? We want to reduce concentration Cl2. Dia tambah Cl2, kita nak kurangkan Cl2. That's it. We want to against the disturbance. Okay, so kalau yang ini ialah disturbance, dia naik. Kita nak turunkan. We try to reduce the concentration. Okay, so this time equilibrium will shift to the right hand side. Kalau dia tambah Cl2, kita kena gunakan dia. Bila awak guna, when you use this concentration Cl2, you are reducing the concentration. Okay, so when you use Cl2, the equilibrium will shift to the right hand side. Okay, so equilibrium shift to the right until QC equals to Kc. Do you get how the Chatelier's principles works? Boleh dapat tak idea PCl3, kalau kita tambah Cl2, kita kena guna, lepas tu equilibrium dia akan proceed to the right. Do you get this idea?
Boleh, madam.
Boleh ya. Okay. And the last point at the bottom over here, concentrations of Cl2, concentration of PCl3 will decrease it. So the last point over here refer to the effect after you done the equilibrium shift. So after the equilibrium shift to the right. So dia punya kesan lah, that effect. Or the consequence. So after equilibrium shift to the right, concentrations of the reactant will decrease and the concentrations of the product, PCl5, increases. Please don't write the words reactants and product, be specific. Sebab awak sudah tahu equation dia macam mana. And you have already recognized which one is reactant, which one is product. So write the specific formula. Tak nak perkataan reactant product unless you tak tahu. Okay, so the second examples we have here, if we remove PCl3. Okay, if you remove PCl3, so madam pandang yang dekat atas ya. Okay, so in this case, if I remove PCl3 over here as a reactant as well. Okay, so removing of PCl3 indicate that the concentrations of PCl3 will decreases. Okay, will decrease. Okay, will decrease. So your KC value is greater, so QC value is greater than KC. Macam mana nak tengok Okay, so over here you have smaller concentration PCl3. That means you have a bigger value for QC. Therefore, it means that your system is not at equilibrium. And then to apply Chatelier's principle to regain equilibrium, system will try to reduce disturbance by increasing PCl3. Okay, so dekat sini ada pembetulan please do your correction. Maybe I forgot to change the words. Okay, because we want to against the disturbance. Kalau dia turunkan concentration, kita nak naikkan balik dia. Okay, by increasing the concentrations of PCl3. Therefore, if this is our aims, we want to increase back the concentration. So which direction it will shift? Kita nak naikkan balik concentration dia. In which direction it will shift? Towards the left hand side. So please do a corrections over here. Okay, reduce the disturbance by increasing PCl3. The equilibrium position shift to the left until QC equals to KC. So the effect after the shift, concentrations of your reactant will increase since the reaction is now proceeding to the left hand side. So you're producing more reactant and then reducing the concentrations of product. Do you get this? Is it clear?
Yes, madam.
Yes, madam.
Okay, kita test sekali lagi ya. So, tadi kita ada cakap CL2, PCl3. So, I give you one more scenario. You let me know in which direction it will proceed. So, let's say if I decrease the concentrations of PCl5 or I remove PCl5, which direction it will shift? Left, right?
Right.
Right.
Okay. So PCl5 decreasing concentration. System will adjust. You want to increase back the concentration, therefore reaction will shift to the right. Very good. Okay. Madam rasa, bukan rasa lah, memang ada yang tak faham, cuma tak bagi tahu. Okay, I give you another analogy. Okay, using the analogy of our seesaw just now. Okay, so let's say Madam say PCl5 concentration is smaller. Masih guna example yang sama PCl5 you have a lower concentration ataupun madam keluarkan PCl5 dalam sistem ini. Okay, so now your seesaw originally in equilibrium it look like this. Balance. Reactant, product, balance, equilibrium. But now if I remove my PCl5, so dekat sini ada PCl5 lah. Okay, I removing. Kalau dihasilkan PCl5 saya keluarkan. Dihasilkan PCl5 saya keluarkan. Okay, so the seesaw now is becoming this one. Why? If you remember, if you imagine the concentrations like mass, okay. So if I take out the PCl5, so that means at this side, at the product side, it will become lighter. Sebab awak sudah keluarkan kan, dia lighter. Okay, so PCl5 dekat sini, PCl3 dengan Cl2 dekat sini. Okay, so PCl5 decreasing, right? So it become lighter. So seesaw dia tenggelam dekat reactant side. So now, in order for you to get back the equilibrium position, okay, the seesaw, you need to go into the right hand side. Do you get this idea? So proceeding to the right so that your seesaw will be balanced back again.
Yes, madam.
Okay. Boleh kita tengok contoh lain pula. Okay, so down at the bottom here you have two questions. Please take note on the face. NH4HS solid, NH3 gas, H2S gas. And the equations have already balanced. So based on the chemical equation, predict the equilibrium shift. You have three scenarios. The first one, add more NH4HS. So where is the equilibrium will shift to? Towards the left, towards the right? Any idea? Kalau awak tambah NH4HS.
No effect.
No effect. Why is it no effect?
Solid.
Solid. Well done. Okay, so because of the solid phase of NH4HS, okay, when you're adding more of the solid, you're adding more of the solid, nothing happened. Okay, nothing happened. So you may say that the equilibrium position remains unchanged. Boleh catat dalam awak punya nota. Equilibrium position remains unchanged. So if you want to explain, because NH4HS is a solid and has constant concentration. Constant concentration is the key words when you're having the phase of solid or liquid. Do you get the idea? Boleh tak ikut, madam?
Boleh.
Boleh, madam.
Boleh, masih tidur.
Ya,
Adalah kan?
Mana ada, tak tidur, tak tidur.
Okay.
So, madam,
Yes.
basically speaking, if it's solid or in aqueous solution,
Not
it will
aqueous,
affect
Azim. Not aqueous, solid and liquid. Aqueous
liquid.
has concentration. Okay, aqueous has
So
concentration.
if it's in solid and liquid form, it won't exactly change the equilibrium.
Yes. It won't change at
So,
all. So,
so this only apply on gas only.
solid and liquid. So if you got aqueous or
No,
gas,
the change of equilibrium only applies on gas only, right?
and aqueous solution, concentrations,
Alright.
concentration, awak kena ingat balik ya, ini awal-awal chapter 6.2 kot. Aqueous and gas, we have concentration. Kejap tukar sikit. Okay, kalau awak nampak AQ stand for aqueous, you have gaseous phase, that means we have concentration. If you see solid or liquid, that means we have no concentration. Mana bagi short form je lah ya. Okay, kalau untuk gas, selain concentration, it can have partial pressure as well. Okay, tapi kalau untuk aqueous, untuk solid, untuk liquid, dia tak ada partial pressure lah. Is that good?
Yes, madam.
All right. Okay. How about the second scenario? Removing H2S. Where will your equilibrium shift to? Removing, that means you're decreasing the concentration, yeah? Proceeding to the left or to the right? Mana pilih orang? Kejap, ya. Okay, so see who is the luckiest one. Okay. Chia Chai-Xing, are you there?
Yes, madam.
Okay,
Thank
how do
you.
you say? Is it to the left or to the right?
To the right.
To the right. Why do you say so?
It is because the product decrease and we must shift from the reactant to the product to achieve the equilibrium.
Very good. We want to achieve equilibrium. So if the system decreasing the concentration, we need to put it back. We want to replace it. Very good. Well done. So equilibrium will shift to the right. So kalau tengok pada equation sama jugalah, removing that means you decreasing the concentration. Therefore, the equilibrium will shift to the right. So sama macam PCl5 tadi kan. You can actually use the seesaw to help you to understand better. Okay, one more lucky one. So this time I want Farihin Nordin. I want a boy. Farihin, are you there? Farihin, Hin. Where is Farihin? Farihin. Tak ada. Farihin 1, Farihin 2, Farihin 3. Tak ada. Kalau tak ada, I choose the next one. Azrai?
Yes, madam.
Yes, Azrai. So is the equilibrium will shift to the left or to the right? Kalau, sorry? For the third scenario, if I add more NH3.
Madam, saya
Yeah?
Madam, tadi
Awak
Farihin.
Farihin, okay.
Dah tadi awak Farihin.
Farihin, okay. So Farihin to the left or to the right for the third scenario? Add more NH3. Add more NH3, that means we increase the concentrations, right? So towards the left or towards the right?
to the left.
To the left. Reason? What is the reason? Dah betul dah to the left, but I want to know about your reason. You know, like every time you give an answer, you must have a
Left.
reason. Nah, kalau awak tak dapat nak explain, maksudnya awak tak faham dan mungkin jawapan akan salah.
Sama ke
Left
atas
kenapa?
sebab dia lelaki
Using your own words.
tinggi. So,
Apa yang awak faham saja. No need a very proper sentence. Apa yang awak faham je. Ting tong. Tong tong.
sebab dia
Ada.
nak
Hey, Farid, to the left.
equilibrium.
Sebab dia nak equilibrium. So, kita nak turunkan concentration NH3. Kena ada reason. Reason for yourself. Why am I doing so?
Kalau
Kenapa awak nak study? Sebab saya nak score well. Okay. So, add more add more NH3. That means you're increasing concentrations for NH3.
dia kalau
Tak apalah ya. Kerana kalau awak dapat explain to yourself, that will be
lagi
good.
banyak tu,
So adding more NH3, that
kena
means
pergi tempat
increasing
lagi
the
kecil.
concentration NH3.
Cepat lagi sikit untuk
Okay, accepting. Accepted. Your answer is accepted. So, nak pergi ke sebelah dekat sat yang lagi kecil kan? Okay, supaya awak dapat menurunkan concentration NH3. Okay, try to explain everything for yourself. So we proceed to question number 2. Thank you, Farhin and Chasi. So question number 2. So you're given CH3COH in aqueous. Okay, H2O liquid in equilibrium with CH3COO minus aqueous and H3O positive aqueous. So based on the chemical equation, predict equilibrium shift. So the first one, to the left, to the right.
Right.
Volunteer this time. So increasing concentrations of CH3COOH. So the equilibrium shift to the right. Okay, so to the right. Or you may say in forward direction. How about the second scenario, removing water?
No effect.
No effect, or the equilibrium positions remains unchanged. Boleh tulis ayat penuh tapi Madam catat dekat sini remains unchanged saja. Okay, so apa yang remains unchanged? The equilibrium shift or equilibrium positions remains unchanged. Alright, so this is about equilibrium. This is about concentrations factor.
Madam,
Any questions? Concentration? Yes.
untuk yang ni kan tak ada calculation.
Tak ada. Yeah, mainly explanation, so it is slightly easier for you to understand lah. Okay,
From this
6.3
topic
explanation.
onwards memang tak ada calculation ke?
Untuk 6.3. Chapter 7, banyak. Chapter 7 paling pening Bina. So for those who think, sorry?
What do you mean paling pening? Is it because of calculation?
Paling pening ah. Nanti awak masuk chapter 7 awak akan nampak kenapa Madam cakap pening ah.
Oh lawa.
Hai Hazim. Yang ini kalau siapa yang rasa susah dah, okay, you kena buat practice banyak. Sebab chapter 7, kita akan guna balik ice table. But the concept is much more complicated. But get ready for that one lah. Madam will guide you one by one, don't worry. Okay, so we proceed to the next factor. Okay, so remember that the factors of pressure and volume, they are under one factor. So let's say if the questions ask you to suggest what factor will affect equilibrium shift, pressure, volume, consider as only one factors. Okay, so the change in pressure or volume only for the system that involve gaseous component. So gaseous component are affecting the factors under pressure or volume. So pressure of an equilibrium system can be changed by changing the volume. So actually what laws is applying? If you're adjusting volume, then it responds to the pressure. If you're adjusting pressure, it responds to the volume. What is this law? Laws apa yang dia adjust antara pressure dengan volume? It's underneath your gas law, last chapter.
Boy's law.
Very good, thank you. Boy's law. Okay, Boy's law. So if you're having a larger volume, in this case, the volume refers to volume of container. Larger the volume, lower the pressure. Smaller the volume, higher the pressure. Okay, so in this diagram, I also give you the definitions of pressure lah. Pressure, it refer if you have a low pressure, it refer to you in the system, you have fewer collision per unit volume. Okay, because pressure, it refer to the number of collision between the particles and the wall of container. So if you say you have low pressure, it refer to a lower number of collision. But if you have higher pressure, that means you have more collision between the particles and the wall of container. So actually from the diagram, you can see yourself. You decreasing the volume, the distance getting closer and closer. That means your frequency or the number of collision will increase in the smaller space it has. Okay. So we want to see how this changing in pressure or volume will leave an effect for the equilibrium position. So now we're using this example, yeah, SO2, O2, SO3. So all species are in gaseous state. Okay, we'll look at the first column first. So this time, your disturbance says that if I increase the volume of the container, so when you're increasing the volume, you need to link straight away to the pressure. So increasing volume means you reducing the pressure of the overall system. Now all the container lah. So reducing pressure. Okay. So when the pressure of container is increased, gas pressure decrease. So according to your Boyle's law. Okay, so volume increase, pressure decrease. The system is not at equilibrium. And in order to re-attain equilibrium according to Chatelier's, the system will try to reduce the disturbance by increasing back your pressure. Dia nak against dia kan. So to increase the pressure. Kalau awak turunkan pressure, kita nak naikkan dia balik. Okay. So equilibrium position will shift to the side with higher number of mole of gaseous molecule. So yang ini penting shift to the side with higher number of mole of gas molecule. So back to the equation. Okay, so this will be your reactant side. Tell me the total number of mole you have seen from this balance equation. How many mole are there?
3.
Think
3.
3. You have 2 mole SO2, you have 1 mole O2. So total dekat reactant side ada 3. How about on the product side? Product side ada berapa?
2.
2 only. So which value is higher? 3. So that means your reactant side having higher number of mole. So in this case, if I want to increase back the pressure, we need to shift to the side with higher number of mole. Lagi banyak particles ataupun lagi banyak molecule, you are resulting at more collision. So if you're having more collision, that means you are increasing the pressure. So definitions for pressure, you need to take notes. Definition. Tapi boleh jugalah cari daripada nota chapter 5.1. Pressure refer to the number of collision. Catat ya. Between gas particle and the wall of container. So of course, it will between the gas particle itself and between the gas particle and the wall of container. So if you have more collision, that means higher pressure. Smaller number of collision will resulting in low pressure. So in this case, the equilibrium will shift to the side with higher number of mole. It means it is shifting to the left. To the left, according to the example equation. Do you get the idea? Dapat membayangkan? Membayang dapat Good. No, good. Good, no, good.
Good, madam.
Tapi the very important thing, you must make sure the equation is balanced. Okay, so the effect after the system shift to the left, the concentrations of SO2, O2, the reactant will increase, but the concentrations of product SO3 will drops. Minta maaf madam punya grammar. Sometimes cannot tahan juga. Okay, so concentration SO2 decreasing. In this case, the effects over here, if the questions ask for concentration, we can explain concentration. Over here, you can also take note. Kalau dia minta pressure, you can also say like this. The partial pressure of SO2 and partial pressure of O2 increasing. Partial pressure for SO3, the product decreasing. So it can refer to both quantity, concentration or partial pressure. Okay. So let's just look at the next disturbance. Okay, so disturbance if I reduce the volume of container. Reducing the volume, we will increase the pressure of the overall system. So volume container decrease, gas pressure increases. So the system is no longer at equilibrium. So in order to reattain the equilibrium, system will try to reduce the disturbance by reducing the pressure. So now the pressure is high already. We want to against it. We want to lower down the pressure. Okay, therefore the equilibrium is shift to the side with a lower number of mole of gas molecule. So is it towards the right or towards the left? Dia nak bergerak ke mana? Kiri ke kanan?
Kanan.
Kanan. Okay, because the overall number of mole now is lower at the product side, the right hand side, right? So at this point, the reaction will proceed to the right hand side. Oh, Madam ada tulis tak nampak. Ada ke sini ada. Okay, so the effect, the consequence after the reactions move to the right, concentrations of reactant decrease or the partial pressure decrease. So the partial pressure or the concentrations of your product will increase. All right. So any question for this example?
Untuk example ni pun masih guna yang sisa.
Sorry, Madam tak dengar. Boleh mention sekali lagi?
Untuk yang ni pun masih guna sisa tu.
Yang ini tak guna seesaw. Seesaw hanya apply kepada concentration. Sebab yang ini yang kena relate adalah definition pressure. Lebih banyak collision ke lebih kurang collision? Nak naikkan pressure ke nak kurangkan pressure? Itu je.
Okay, Madam.
Alright. Okay.
Madam,
Ada? Ya?
Madam boleh tak ulang balik yang belah kanan?
Daripada point mana ke semula semua?
Semula tapi yang kotak belah kanan je sebab tadi putus.
Untuk yang increase pressure ya?
Yes.
Okay. So, Madam mention sekali lagi lah tapi kejap ya. Okay, so for the second disturbance here, if you reduce the volume of container, you must link to pressure anyway. Kalau dia adjusting volume, you need to relate to pressure. Tapi kalau dia terus bagi pressure, okay, boleh teruslah awak punya explanation. Okay, so when a volume of container is decreased, the gas pressure increases. The system is not at equilibrium. To reattain equilibrium, by applying your Chatelier'S principle, system will try to reduce the disturbance by reducing. Kalau awak naikkan pressure, kita kena turunkan pressure. Will reduce the pressure. Okay, so remember, in order to reduce the pressure, you need to shift to the side with lower number of mole. Macam mana nak tengok lower number of mole? You come back to our equation over here. On the left, sebelah reactant side, you have 3 mole in total. And then on the product side, we have only 2 mole in total. So carilah mana satu side yang lagi rendah dia punya number of mole. Okay, so in this case, we want to shift to the lower number of mole. Therefore, you need to shift the equilibrium towards the right hand side. Sebab 2 lagi rendah kan value dia. So when you identify the positions, right, the equilibrium shift to the right, then you have to let us know what is the effect. So after equilibrium shift to the right, the concentrations of reactant or the partial pressure reactant, SO2, O2 decreases. But then for the product side, it will increase because now you shift your equilibrium towards the right hand side. So product, partial pressure, or the concentrations will increase.
Madam.
Ya.
Kalau soalan tu dia nyatakan volume dia increase atau decrease, and then dia cuma perlu ubah pressure. Kalau dia mention pressure tu increase atau decrease, kita tak payah mention volume terus mention pressure.
Tak payah. Tak payah. Dia punya main point adalah pressure sebab kita kena tahu dia shift ke side mana kan. So kalau dia mention volume, you relate kan kepada pressure. Kalau sudah tahu pressure dia increase atau decrease kan, boleh terus adjust dah. Tak payah relate balik volume pun tak apa. Nak relate pun tak apa. Tak ada masalah punya. Okay?
Okay, madam, faham.
Alright. So kita try soalan ya kat bawah. Alright, again 2 questions. So after this question, we will take a 5-minute break. Yeah? So question number 1. PCl3 gas, Cl2 gas, PCl5 gas. Predict the equilibrium if the volume of the container is reduced. So try to have a guess. To the left or to the right, it will proceed. Jadi tengoklah, you typing dekat ruangan in-call message. Siapa yang rasa to the right, you type 1. Anyone think is on the towards the left, you type 2. Let me see. Towards the right, majority say that. Okay, very well done. Okay, so let's see the explanation how. When your volume of container is reduced, what happens to the pressure? What happens to the pressure?
Increase.
Okay, pressure will increase, isn't it? So if we want to we want to apply Lee Chatelier principle, what we have to do towards the disturbance?
Decreasing
Reduce.
Reduce pressure.
the pressure.
We need to reduce the pressure. We need to get rid of the disturbance. Reduce the pressure. Sebab pressure dia naik kan sekarang. Okay. So now you refer back to your balance equation. Okay, so reactant side, we have 2 mole in total. Product side, we only have 1 mole. So to reduce the pressure, you need to, kita tulis dekat sini, awak boleh catat Okay, equilibrium. Hold on a second. Equilibrium position will shift to the side with lower ke higher number of mole. And it shift to the lower or higher? Lower kan? Okay. So beside you saying lower number of mole, you can also say shift to the side with fewer, lower or less mole of fewer mole of gas molecule. And then in bracket, you need to indicate, is it towards the left or towards the right? Okay, so kita tulislah to the right hand side. So the effect you can either you can either choose you want to write or not lah, if the question didn't mention. So if you want, we can add 1 more point over here. Let's just see partial pressure lah. Partial pressure of the product PCl5. Is it increasing or decreasing? After equilibrium shift to the right, what happens to the pressure? PCl5 increase.
Increase.
So partial pressure,
Increase.
PCl3, PCl2 will
Decrease.
decrease. Very good. Okay, question number 2. Again, balance equation is given. Predict the equilibrium position if the pressure of the system is reduced. Okay, again, the same thing. Right 1, left 2, no change, 3. So in a column, in the message over there, what do you think the answer is? Beda bagi jawapan lain ni. Okay, anyone want to tell madam why you choose 3?
The number of mole
Number
is
of
the same, I think.
site is the same.
Okay, first of all, you check. Okay, all the species are in gas. So that means they can have the partial pressure, isn't it? And then reactant side, we have 2 mole. Product side, also 2 mole. So anyhow, shifting to the left to the right, you're still getting the same thing, isn't it? So there is no change. Very good. Good try. So nampak tak dia punya explanation macam mana? Macam mana nak predict equilibrium shift? Is that very good?
Madam,
Yes, I do.
Yeah.
kalau pressure of the system tu maksudnya yang dalam container ke?
Ya, betul.
Okay, madam.
Alright. So now we have done for the factors of concentrations and the factors for pressure. Take a 5-minute break. So now it's 9:07. We come back in 9:12, yeah? You gotta have a breakfast. Bukan breakfast, a break first. Bagi tandas ke, nak bagi minum sikitnya. Alright, 5 minutes. See you afterwards. Alright, so can we continue for the following explanation, following factors? Is everyone back already? Can you listen to madam? Can you hear me?
Boleh.
Yes, madam.
Yes, madam.
Alright,
Can.
so
Yes, madam.
can. So we continue for our next factors. So for these factors, the next two factors are additions of inert gas and temperature is slightly difficult, but you try to understand and try to follow. Okay. So we start from additions of inert gas. And then we have two factors. I remember we have the additions of inert gas at constant volume or at constant pressure. So the first one, additions of inert gas at constant volume. So additions of inert gas does not have any effect on equilibrium position. So you must remember, if you add something, you add your inert gas. Apa dia inert gas? Madam lupa nak tanya pula. What is an inert gas?
Gas nadi. Ya ke?
Gas that wouldn't react with any
Noble
other
gas.
occurring substance.
Okay, it's a non-reacting species. It's a noble gas. You can give Madam any example.
Neon,
Any
Helium.
example?
Helium.
Neon,
Helium.
helium, apa lagi?
Argon.
Argon.
Argon,
Krypton.
xenon, krypton.
Kanan.
Okay, banyak juga kan? Okay, untuk group
so
18.
then it's still considered as noble gas,
Yes.
even though it still can react with other substance, right?
Yes, it is still under your group 18. Okay, so they are inert gas that won't react with anything containing inside the container. Okay, so at this point, if you add some of this noble gas into the container at constant volume, another meaning of constant volume, that means you didn't change the volume. If the volume of the container too little, then it will fix at too little. So it doesn't have any effect on equilibrium position. So let's look at the explanation. The total pressure of the system increases. So if you fix the volume, pressure of the container of the system will increase. But the partial pressure of each gas remains the same. So partial pressure of the reactant that originally inside the container or the partial pressure of our inner gas will remain unchanged. So since the partial pressure is the same, therefore there is no effect on your equilibrium position. And the concentrations of all the reactant and the products will remain the same. We look at the analogy over here. I'm just using a diagram, a simple diagram. So if let's say we want to keep this system, this container at fixed volume. So let's say too little. So now saying that I have gas A, gas B inside my container. Okay, and the pressures over here, so let's say each of them having 10 atm. 10 atm for gas A, gas B. So the total pressure over here, pressure A plus pressure B, 10 plus 10 will give you 20 atm in total. Okay, but then if you fix the volume of the container as 2 liter, right? So that means gas A, gas B. Now I'm putting in one more inert gas, which is neon or helium or argon or whatever inert gas lah. Okay, so the pressure of this species A and species B are still the same. So let's say the additions of inert gas I also put as 10 atm. So now in your second box, second container here, the total pressure equals to gas A plus gas B plus your inert gas neon. Okay, so the volume is constant now. That means you can respond to the total pressure and the total pressure will increase. So to keep the partial pressure the same. So partial pressure A, B, and neon, they are still remains 10 atm. So in this time, the total pressure becoming 30 atm. So the important points over here is here. If there is additions of inert gas, look at the partial pressure. If the partial pressure didn't change, no effect on the equilibrium shift. But if your partial pressure change, reduce or increase or whatever, there will have some effect on your equilibrium. Okay, so please remember, constant volume, no effect on equilibrium shift. So until this part, are you all right? Is everyone all right with this? Yang penting awak punya partial pressure semua tak berubah. Are you good?
Yes,
Okay,
madam.
madam.
Okay, so you will see it very obvious when we keep the pressure constant. So kita tengok apa perbezaan eh. Okay, so go at the bottom here. Alright, so at constant pressure, when your inert gas is added, the total pressure increases. Supposedly, right? So bila awak nak tambah gas, total pressure dia automatic akan increase. But our criteria, our condition now is happen at constant pressure. Maksudnya kita kena tahan. Kena maintain total pressure dia sama. So when you maintain the pressure, you try to keep the pressure constant, you must increase the volume. Okay, so in order to maintain the pressure, the volume of the system or the volume of the container must increase. So at this time, your partial pressure of each of the gas, including the inert gas, will decrease. Now, inert gas tak adalah sebab dia tambah kemudian kan. So, partial pressure of the gas inside the container originally will drop. So, partial pressure of each gas decreases. So, when you affecting the partial pressure, that means you have to do something to increase back the partial pressure of this species. Maksudnya partial pressure sekarang sudah terganggu. Dia adalah awak punya disturbance. So in order to return to equilibrium position, okay, you need to adjust the volume again. So this additions of inert gas at constant pressure, you can refer back to the factors of pressure. So now the disturbance, partial pressure decreases. In order to raise back the partial pressure, you need to shift the equilibrium to the side with higher number of mole of the gas molecule. Okay, to increase back the partial pressure. Do you get the idea? Macam tak faham. Okay, macam tak faham kan? Kita tengok diagram pula. Okay, so let's say over here in the diagram. Inside your notes also have lah. Okay, so say if initially, okay, you have gas A and gas B inside container here. So in this container, it's maintained at 1 liter. Initially at 1 liter. Okay, so the total pressure before adding the helium, okay, before adding the helium, the total pressure you keep pressure for gas A, pressure for gas B, each of them 10 atm. So in total, the total pressure is 20 atm. So now you want to put an inert gas, but this inert gas, it won't react with gas A or gas B. Okay, it's non-reacting species. Okay, so at this time, after adding your helium, so inside the container here, I have A, I have B, I have helium. Okay, but you need to maintain the pressure as 20 atm. Gonna maintain sebab dia punya condition at constant pressure. So if I want to maintain the total pressure, then I have to do something with my partial pressure, isn't it? Ini simple mathematics lah, boleh practice. Okay, say kalau dekat sini tak ada contoh kan, Madam bagi contoh. Okay, PT plus PA plus partial pressure B plus partial pressure helium. So kalau kita macam tadi, additions of helium is 10 atm and I need to keep the total pressure 20 atm. What happens to partial pressure gas A and gas B? What is the value? You can try to guess. If
5-5.
originally 10-10.
5-5.
5-5,
Decreases.
right? Sebab dekat sini kalau tengok total 20, helium sudah 10 atm. So, anyhow, you have to decrease the partial pressure. Untuk keluarkan satu ruangan untuk addition inner gas. So now, your partial pressure A, partial pressure B decreases. Okay, so remember just now I said if partial pressure didn't change, no equilibrium shift. But if your partial pressure change, equilibrium will shift to the side to against the disturbance. So we back to the sentence again. So if the partial pressure of each gas decreases, the equilibrium will shift to the side with higher number of mole. Okay, to regain the pressure, to increase back the partial pressure. So if let's say we're using the example in this one, towards which side you want to move, which is the equilibrium shift, to the left or to the right, in order to increase back the pressure.
Left.
Towards the left, because here you got 2 mole of A, here you only got 1 mole of B. Okay, so to raise back the partial pressure, to increase back the overall pressure, right? To maintain the overall pressure, we need to regain the equilibrium. So shift to the side with higher number of mole. Okay, and then we compare between these two conditions. Constant volume, no change partial pressure, no change in equilibrium. At constant pressure, partial pressure decreases. Therefore, equilibrium will shift to the side with more mole of the gas molecule. Is there any questions for the factors additions of inner gas? Ada soalan? Tak ada soalan maksudnya? Senyap maksudnya?
Semua okey, madam.
Power.
Silence
Sir
and not
takat
lecture.
ni.
Okay. Madam, I guess lah some of you might confuse about this factor, but you have to keep on going through. Kalau tak faham, keluarkan satu diagram macam apa yang Madam buat dekat sini. So, bolehlah refer balik. Okay? Kalau ada soalan, boleh tanyalah. Alright, so 9:20. Kita try one more questions, then we will stop for today. Untuk effect temperature, effect catalyst, Madam will do a video. Like what I mentioned in the Telegram group, right? Madam will continue a short video, and then through the app puzzle, that will be a replacement class. Okay, so starting from tomorrow until Sunday, you're having your Timabali holidays, right? But on Madam doesn't fix any time you want to do lah. Once Madam dah siap video, Madam akan up dalam our mini Telegram group. Following your own time, you can do it, but before complete it before Sunday, by Sunday. Okay, instructions clear.
Okay, madam.
Yeah. Yes, madam.
Okay, so dalam beberapa hari ni sebelum Madam jumpa awak nanti, jumpa awak pula. Sebelum 7 lah, the last day is 7th of November. You have to complete your puzzle and also the topical test 5. So topical test, Madam akan bagi sehari sajalah. Maybe I will give you the last day. So completing throughout the day. Doesn't matter lah what time you all do. So once Madam bagi link, awak boleh start buat. Lepas tu hari Isnin nanti, 8th of November, Madam akan terus collect respon. Madam akan tengok awak punya result. So make sure you done it before 7. Depends on when Madam share the link. So anything, refer to your Telegram for announcement. Is everyone okay?
Yes, madam.
Alright, yeah. Alright, kita try satu soalan lagi dekat sini. Okay, so question number 1, the formations of sulfur trioxide SO3 gas is shown as the following reaction. Okay, so kita highlightkan di sini. So this is your balance equation. By using Chatelier's principle, predict and explain the shift in equilibrium position, if any. So mungkin tak ada, mungkin ada. So the first scenario, if you increase the if the volume of the vessel means container, yeah, is decreased. So in which direction? We can do it one by one, yeah. So if let's say volume of the madam, what can short form? You can write in your own sentence. Can refer back to the notes how to make sentences. So volume decrease, what happens to pressure?
Increase.
Higher.
Increase.
Okay.
Betul. Volume decrease, pressure increase. Okay. So what we need to do for the pressure? So need to. Yang ini short form kena ayat penuh dah. Madam buat ayat penuh lah. Nanti awak cakap, Madam tak buat ayat penuh pun. Okay, so to regain equilibrium. Okay, the system. You all continue. Ayat dia macam mana? The system?
Will shift to
The system will reduce the disturbance. Tak nak tulis reduce disturbance pun tak apa. Tapi dia, awak kena tahulah kenapa. Kena tahu macam mana kita nak reduce disturbance. Maksudnya yang buat garisan ni penting. Okay, so to regain the equilibrium, the system will reduce the disturbance by
decreasing the pressure.
decreasing, lower down the pressure, or to reducing the pressure. So where is your equilibrium shift? Equilibrium will shift to
the right.
Right.
The right.
Right.
Sebelum right. Sebelum right apa yang awak kena mention dulu?
To the side.
Lower
To the
number of
side.
mole.
Higher number of
The
mole.
side with
Lower.
fewer with lower mole of gas. Boleh nampak kan Madam punya tulisan? Okay, with lower mole of gas molecule. So is it towards the right or towards the left?
Toward the right.
Right.
To the right. Okay, to the right. So what happens to the pressure of SO3? Increasing, decreasing?
Decrease.
Increase.
Increase. Pressure of SO2, O2?
Decrease.
Decrease. Okay, so dia punya pattern lebih kurang macam ni lah. Okay, so Madam highlightkan awak punya keywords. You need to write by reducing the pressure. Okay, shift to the side with lower mole of gas molecule, and which is to the right. This is the important key. All right, and how about scenario 2? The oxygen gas is added to the system. So this time Madam didn't explain now, but Madam want to know what is the equilibrium shift. Since a question asks predict to explain, you need to practice how to write the sentence. So oxygen is added to the left or to the right? Left, right, left, right. Right, left, left, right. Oxygen gas is added. This is your oxygen gas. Added means you increase the concentration. So the equilibrium will shift to the right. Okay, Madam just give you the directions only. How about for scenario C? Neon gas is added to the system at constant volume.
No change
No
in
change.
equilibrium.
Constant volume, total pressure will increase, but the partial pressure remains unchanged. So in your explanation, you must mention the partial pressure of each gas remains unchanged. Therefore, there is no equilibrium shift, no change in equilibrium shift. Okay, so you must remember about the condition. Constant volume, no change. Constant pressure, what happened? So according to the explanations you have. Is that alright? Explanation dia sama sebiji macam tadi. Kalau untuk addition inner gas kan, explanation sebiji macam tadi. At constant volume. Kenapa? Pressure, each gas remains the same. No change in equilibrium. So, sama je dekat sini. Kalau concentration, boleh rujuk lah dekat factor concentration. Okay, so any question for your question number 1? Tang. Ada soalan? Tak ada
No,
soalan?
madam. Okay.
Okay. So the rest of your chapter 6.3, madam will record the video and update you later, yeah? And I think that's all for today. Another half an hour, you can practice your questions. Boleh baca dulu tak apa. Factors of temperature need to interpret a little bit. Factor temperature dia kena ada teknik lah untuk jawab soalan. So before I forgot, we fill in the attendance. So the link of your attendance is in the in-call messages.